Now, in this video, we are going to take up one more problem on projections of laminas. The problem reads as a regular hexagonal lamina of side 30 mm is lying in such a way that one of its side touches both the reference planes. If the side opposite to the side on which it rests is 45 mm above HP, draw the projections of the line. So here, he has given that one of the side touches both the reference planes. What does it mean? The reference plane means it is the intersection of horizontal plane and the vertical plane. So the reference plane is the horizontal plane and also the vertical plane, which means that it touches one of its sides touches both the reference planes. If the side has to rest on HP and also on the VP also, it means that the side which is touching HP has to be touching VP also. So that is the meaning. If the side opposite the side on which it rests is 45 mm above HP, draw the projections. How to start the problem? So as he says, it is resting on HP. So obviously, we have to start the problem from the horizontal plane. Point number one. And the point number two is, since the edge is resting on HP, make that edge perpendicular to VP. So that is the condition. You can see here, the edge CD is perpendicular to VP, and here also the edge AF is also perpendicular to VP. The side opposite to the side, which is the side opposite to the side? The side opposite to the side is AF. If CD is resting on HP, then AF will be above HP by 45 mm. So that is the meaning of that. So here, in the initial position, if the side has to be perpendicular to VP, that means the entire surface will going to be perpendicular to VP and parallel to HP. How do I know that it is parallel to HP? When you look from the front view, you can see that all the sides are resting on XY line. So obviously, those sides are parallel to HP. Since those sides are parallel to HP, so you are getting the true length in HP. So what is the true length of the side? The true length of the side is the regular hexagon of side 30 mm. So that means the side AB equals BC equals CD equals DE equals EF and equals FA, which is equal to 30 mm. So this is how we will be able to analyze in the initial position that we need to start the lamina, hexagonal lamina on horizontal plane, and also keep the side perpendicular to VP so that it is resting on the horizontal plane. So that is how we will going to write this. Now how to write it in orthographic view? First we are going to draw the XY line and mark VP and HP. Once you do that, first you draw one vertical line of any length. You take the radius of 30 mm by using the compass, any point on this vertical line, and draw a circle of radius 30 mm. So that that circle will going to cut at this point and also at this point. Then with this as center, taking the same radius of 30, cut it on the circumference of the circle here and also on this side. Similarly, with this as center, with the same radius of 30, cut it on this side and also on this side, on the circumference of the circle. Then you mark these points A, B, C, D, E and F. Once you do that, then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So that will going to form the hexagon of side 30 mm. Then I need to write the front view. So draw a vertical projector from A and F to the XY line. Similarly, draw a vertical projector from B and E to the XY line, and similarly from C and D to the XY line. As you look from the front view, ABC is near to the observer, so A dash, B dash and C dash is visible, and DEF is away from the observer, therefore D dash, E dash and F dash is invisible. As we have joined between A to B and B to C here, similarly you join between A dash and B dash and B dash and C dash. Of course, CD is perpendicular to VP and also AF is perpendicular to VP. Therefore, you are getting a point here and also here. So this is how you will be able to write and join A dash to C dash with a dot line. So this is how you will be able to write the initial position of the hexagon in both top view and as well as in the front view. So this side, now the hexagonal surface is parallel to HP and it is perpendicular to VP. Since it is parallel to HP, so you are getting the true shape here. Since it is perpendicular to VP, you are getting a line on the XY line. So once you do that, now he says the side opposite to the side, resting on one of its side, one of the side is touches both the reference planes. So here one should do that, and the side opposite to the side is above HP by 45 mm. So what does it mean? The side opposite to the side, which is C dash and D dash, is one side and A dash and F dash is the another side. In this initial position, both these sides are on HP. But what he says, one of the side is, the side opposite to the side is above HP by 45 mm. And the one of the side touches both the reference planes. That means if you are considering C dash D dash on XY line, you can see here C dash D dash is on XY line. So we are rotating this hexagon in the top view such that AF will be above HP by 45 mm. So AF will be above HP by 45 mm, in the sense that you are rotating this hexagon such that AF will going to become above HP by 45 mm. If I look from the front view, above HP will going to be seen in the vertical plane. So therefore, you will be able to get this particular figure in 3 dimension. As we are rotating this in space, what happens to the image? Image will going to be being rotated in the front view. So how does it does? So we are rotating this particular line such that A dash F dash will become above HP by 45 mm. Till A dash F dash will going to become 45 mm. Till to such distance you will be able to rotate. Once you do that, then what happens? This three-dimensional line, hexagonal surface will going to become like this. Okay, when you look from the top view, these projection points will going to be on the horizontal plane. So we have A to B, B to C, C to D, D to E, E to F and F to A. This is the top view of the image, what you will going to get here. Now, how to draw it in orthographic view? So what we have to do is, from the XY line, you measure 45 mm, draw a horizontal line, and you take any convenient distance between this point to this point, and you mark that point as C dash and D dash. So by using the compass with C dash as center, taking the radius of C dash A dash with C dash as center, cut an arc on that 45 mm line. So then join between A dash and C dash with a dot line. Then using the compass, you measure the distance from C dash to B dash with C dash as center, cut an arc on that inclined line and mark that point as B dash. And similarly, you mark this point as D dash in bracket, A dash is in bracket and F dash is in bracket. Then to write the top view, draw a vertical projector from A dash and F dash to the top view and draw a horizontal projector from A and F. These two lines will going to intersect at these 2 points and you mark those 2 points as A and F. Similarly, draw a vertical projector from B dash and E dash and draw a horizontal projector from B and E. Both these 2 lines will going to intersect at this point and also at this point. You mark this point as B and you mark this point as E. Similarly, draw a vertical projector from C dash and D dash to the top view and draw a horizontal projector from C and D. Both these 2 lines will going to intersect at these 2 points and you mark those 2 points as C and D. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So this is how you will be able to write the second position front view and also the top view. Now he says one of the sides touches the reference plane. both the reference plane. Now, which is the side with touching the horizontal plane? Reference planes means what? It is HP and VP. One of the side touches HP and the same side is touching VP. That is how we must interpret. So to do that, so CD is resting on HP. How do I know that CD is resting on HP? So you can see that HP means what? It should be on VP. Where is VP? VP is above XY line. So the point which is on XY line is C dash D dash. The same point has to rest on the vertical plane also. Then to do that, at present, what is happening? The C dash D dash is resting on HP here and perpendicular to VP. Therefore, you are getting a point. Now, to keep this CD on vertical plane, that means you have to rotate this hexagon in a counterclockwise direction such that it will going to be kept on the vertical plane. So, how to do that? You can see here the CD, when you are rotating in counterclockwise direction, C will go to this side and D will going to go to this side. Then this is the position. The orientation will going to be remain the same, but you will going to get the hexagon in this particular fashion where it has been shown with the gray color. Then I need to project this. So when you look from the top view, you can see CD is on VP also, and that is C dash D dash, and CD is also on HP. So one of the side touches both the reference planes. So both C and D and C dash and D dash on HP and VP. So when you look from the top view, A and F is being projected and B and E being projected to HP. CD is already on HP. Then you complete this hexagon here, and when you look from the front view, again E to E dash, B to B dash, A to A dash, and F to F dash. That image will going to fall on the vertical plane. And then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash, and F dash to D dash. So this is how you will be able to analyze this problem in 3 dimensions. Now how to do that on orthographic view? So what I need to do is I need to rewrite the same sketch by rotating at an angle of 90 degree in counterclockwise direction only. If you rotate in clockwise, then what happens? EF will going to come and touches on the XY line. So since I want one of the side should touches, so though the reference plane, the side which is resting on HP, which is CD, is also rests on VP. So you can see that CD is on vertical plane. So what we need to do is you take the distance from C to D by using the compass. Consider any point on this XY line and you mark it from here to here, and you mark this point as C and you mark this point as D. Through C and D, you draw perpendicular in the top view. Then you measure the distance from C to A, which is same as D to F. With C as center, cut an arc on this vertical line, and also with D as center, cut an arc on the same vertical line which you have been projected. Then mark the points as A in this side and F is on this side. Then you measure the distance from C to this point, and from C cut it on this vertical line, and similarly from this D also you cut it on the vertical line. Then join between these 2 points and extend it on either side. Then you measure, because you know this point, I can get this point directly. How? You measure the distance from this point to E. With this point, you cut an arc on that horizontal line. So you mark this point as E. Similarly, if you are measuring the distance from this point to E, similarly from this point to B also will have the same distance. So from this point, you cut an arc on this horizontal line. So you mark this point as B and you mark this point as E. Then join A to B, B to C, C to D, D to E, E to F, and F to A. So this is how I will be able to rewrite the third position top view, such that CD is resting on vertical plane. And then, as we know that C dash D dash is on HP, so you mark the same point C dash and D dash and draw a vertical projector from both F and D to the front view and extend similarly from A to C and extend in the front view. Then you draw a horizontal projector from A dash and F dash and you cut these 2 points here, that is A dash and F dash. Then similarly, you draw a horizontal projector from B dash and E dash and draw a vertical projector from B and also from E. These two lines will going to intersect at this point and at this point. You mark those 2 points as B dash and E dash. Then join A dash to B dash, B dash to C dash, C dash to D dash to E dash, E dash to F dash, with F dash to A dash with a dotted line. So this is how you will be able to write the orthographic view for the problem. Then, how do I know that my problem is right? One of the side touches both the reference planes. The reference planes means on horizontal plane and also on vertical plane. So it touches both HP and VP. So here in the top view, if the line is on XY line, that means it is resting on VP. And in the front view, it is resting on XY line, that is C dash D dash means what? It is the resting on HP. And CD is resting on VP. So both the side, the same side is touches, or one of the side touches both the reference plane. Since we are considering CD as the one of the reference planes, obviously the same CD is resting on VP also. Suppose if you are rotating like this, A dash and F dash is on XY line, and then you rotate this in clockwise, counterclockwise direction, then you need to keep AF on the XY line, because here you are going to get A dash, F dash, and here you are going to get C dash and D dash. So since it touches, since A dash, F dash is touching the reference plane, then you have to keep AF is on VP in the top view. So this is how you will be able to, then the side opposite to the side. The side opposite to the side is AF, is above HP by 45 mm, and then it is a hexagon of a side of 30 mm. So this is how you will be able to analyze and solve manually a hexagonal lamina of 30 mm is resting on one of its sides on HP, and the side opposite to the side is above HP by 45 mm, and the side resting on HP is also resting on VP. So since all the conditions have been satisfied, hence my problem is